Take a look at two more examples now, two more examples of our logarithmic equations to solve. So here I have log of x minus 2 minus log of x is equal to log of 54. Remember, if there's no base written, that's base 10. It's base 10. So what we're trying to do is we're trying to be able to use one of these properties that we know from the previous video. Either if we have a log equal to a log, I set the insides equal. Or if I have a log equal to a number, I turn that into exponential form. Here I'm trying to write this as a log equal to a log because I have logs on both sides. But here I have two logs. I cannot simply drop all of the logs. If you do that on an exam, this is fair warning that you might get 1 out of 10 points. You're almost certainly going to get no partial credit if you just simply ignore the logs and you just solve x minus 2 minus x equals 54. So make sure that you follow the technique that we did on the last example in the last video, of we're going to use the rules of logarithms to combine these into a single log. So when there's subtraction on the outside, this becomes division on the inside. So on the inside, I have log of x minus 2 divided by x. Now I have a log equal to a log, same basis, that the inside's equal. So I have x minus 2 over x is equal to 54. Now I solve this for x. So I have a get rid of the denominator by multiplying both sides by x, and I get x minus 2 is equal to 54 times x. I move this x over here, and I have negative 2 is equal to 53x. Divide over the 53. So I have x is equal to negative 2 over 53. So that is my answer, but it's not my answer because since I combined logarithms using one of those rules, I need to check my answer to see if it works. So I'm going to check. So let's check x is equal to negative 2 over 53. I'm going to plug this into the original everywhere there's an x. So I have log of negative 2 over 53 minus 2 minus log of negative 2 over 53 is equal to log of 54. What are we checking for? Well, we're not checking for the math. Remember, we're checking for the insides if they're being positive or negative. Here, this guy, both of these are negative. So this in particular we see is obviously negative. So what that means, if you have the inside is negative, this is not a solution. And that's the only one we found, so that means that there is no solution. So this is our answer here, no solution. Now you might be thinking, why? Why does this happen? Why do we have to worry about this taking place? When that one example we did, we just had the log equal to a log, I didn't check my answer. Why do we have to be careful now? Well, the reason is because when we do this, when we combine these together, notice they become divided. Here, I have a negative, and I have a negative. When I divide a negative by a negative, the inside becomes positive. So that's why you get this fake solution, is because this has done a negative divided by a negative to get a positive, but these aren't well defined, so you can't even do this at all. So that's the only reason, is that when you do these subtracted or added ones, you might be combining two negatives, and then that's not okay. So this last example over here, log base 2 of x plus log base 2 of x minus 3 is equal to 2. Again, we see this, we should be thinking, I need to combine these logarithms into a single log. So I'm going to use the rule that says I multiply these together. So I multiply the insides. Now, I'm going to combine the inside to simplify first. So I have log base 2 of x squared minus 3x is equal to 2. Now that I have a log equal to a number, if I want to get rid of this log, I turn it into exponential form. So I have 2 squared, so this base raised to the 2 is equal to x squared minus 3x. This is just 4, so I'm going to subtract this, so I have 0 is equal to x squared minus 3x minus 4. So you have a quadratic, you set that equal to 0. Now we solve this using either quadratic formula or factoring. So I factor this as x minus 4 times x plus 1. So x is equal to 4 and negative 1. I have these two answers, but remember, I combined these, so I need to check them. So I'll check them individually. So let's check. X is equal to 4. I plug this in. I have log base 2 of 4 plus log base 2 of 1 is equal to 2. These are all positive. They're all positive, so that's great. I have x equals 4 works for me. So let's check the other. Let's check x is equal to negative 1. I plug this inside. I have log base 2 of negative 1 is plus log base 2 of negative 4 is equal to 2. Well, now, unfortunately, I have negatives on the inside. So negatives on the inside are bad. So this tells me that x equals 4 is the only solution. So there we go. So sometimes, like I said, you might get multiple solutions, but only one of them may work. So again, just kind of go through these videos again in the previous one. If you need to see some more examples, let me know, and I'm happy to make more videos to show you a couple more variations of this, but they're all basically the same ideas of these two ideas of either combining logs to log equal to a log or combining logs to turn into exponential form.